So we're going to look at linear equations, which, what is a linear equation? It's a relationship between two variables that results when you graph it in looking like a straight line. That's what linear refers to, okay? And independent variables. Independent variables, again, if graphing, our independent is always on the x-axis, which is the horizontal, and our dependent is always on, whoops, that kind of all disappeared now, on the y-axis, okay? And we'll make a more permanent version of that. But let's read this question. Car rental A, what a great name for a company. Car rental A charges $40 a day. Car rental B charges $20 plus $5 a day. So very first one, state independent and dependent variables for each relation. Okay, they actually both have the exact same independent and dependent variable. So when we're talking about this, what we're referring to is like the overview of the variables that are involved. Okay, so I'm going to just draw a standard XY. It's called a Cartesian plane. Okay, so our x variables are horizontal and our y variables are vertical. X is always our independent. Okay, that's just a mathematical thing for communicating with other people reading our math. Is one more right than the other? No, you could tactically put independent here, but when we communicate these ideas to stay very standard in mathematics, we put the independent here. Okay, which then means the y, and we'll make it a different color here, is the dependent variable. So we got to decide which is going to sit where. Well, in order to do that, we have to decide which variable controls or manipulates the other one. Okay? In other words, the other one, our y, is dependent on the first one. So I'm going to word these. There are two variables here. One of them is days, okay, and the other variable is money. Okay, so we're going to talk about the two of these. I'm going to use a different color. So we have money and days. So we got to figure out which is independent. So I'm going to say two sentences and you tell me which ones you think makes more sense. Does the amount of money I have No, I don't want to word it that way because that sounds funny. Okay, I'm going to word it one way first. The amount of days I rent a car affects the amount of money I pay. Or, this one's going to sound correct too. I got to word it incorrectly. Does the amount of money I have affect how many days there are? The amount of money I have affect how many days there are. This sounds really odd. They both sound kind of correct, so I'm going to help you out here because I know I didn't do a great job explaining that. Really, our days are independent. Okay, so I'm going to kind of put those in red. Days are going to be independent, and days deal with a variable called time. Okay, minutes, hours, seconds. Anytime a variable is time, it is going to be 99% of the time, that's going to be your independent variable. Okay, money is, again, just money. So money can't actually affect time. If I put $1 billion down, time still passes the exact same. Nothing is going to change, right? Really, there's very few things possible that can affect time. So time's always going to be our independent. So we're going to have days on the x-axis. And money is going to go on our y-axis. That's the dependent variable. So this is a general overview of what our graph will look like. And I know I spent a lot of time focused on just that, but I want to make sure you understand that idea. I know the way I worded it, they both sounded kind of correct, but when we transferred it to time, it makes more sense. Time can affect your money, but money can't really affect time. Okay. Number 2, state an equation for each relation. Well, you guys did a great job of this. You decided to call your money. You said let C equal the cost, right? And that was essentially your money variable. Mm-hmm. And then you guys said let D, was it?
Yeah.
Yeah. Days represent our time or our x variable. Okay, so we'll put that as days here. D for days. So your equations ended up reading, for company number 1, you said that the cost was equal to 40 times D. Yeah, that's correct. If I spend no money, if I don't rent a car for any days, I spend no money. For company 2, you said it was either 5D plus 20 or C equals 20 plus 5. Whoops. 5D, 5 being the coefficient, D being the variable. These are both correct. We're going to relate them to normal equations. So when I say normal equation, I'm talking about when we have y equals mx plus b. Okay, I know, oh, this thing again. Let's relate these two equations to it. Okay, which is which is which. So, what represents y? We've already talked about it before. What was representing y in these equations? We set it up here.
Money.
The money.
Money, yeah. Money, and money was C, right? So C is equal to y, so that sets up really nicely with our equation. 40D, is that your mx or is that your b?
That's your MX.
That's your mx. 40 is your slope, right? So for every day, every 1 day, it costs you $40. And our b, which is our y-intercept, what is that?
0.
0, right? I could technically write the number 0 in here, but it's not that important. And in our other equation, sorry, I forgot to relate also, d, days, was our x variable, our independent, right?
Yeah.
And then here, what is our mx? Is it the 5d or is it the 20?
Your MX is the 5D.
That's right. 5 is your slope for this equation, and 20 is your y-intercept. So when we go to graph these two things, this should really help us out. What I'm going to do is use an online graphing program, okay? So I'm going to write them as y and x, because when we go to graph things, we don't have a axis called the c-axis or the d-axis, okay? So I'm just going to rewrite this equation here. This could be written as y equals 40x, and this one here can be written as y equals 5x plus 20. Okay, so if I was to graph them, that's how I'd write these two equations. So in my graphing program, what's nice is I can write that in, and we get our line. And y equals 5x plus 20. Yeah, okay, I'm going to need a bit of a better axis here. Let's make this go up. That is better. Really needs to go up a 10. -2. That's nicer to look at. Okay. So if you notice here, okay, we now have our two lines, right? And for these lines, they do have a point of intersection. It actually occurs right before our very first day, okay? And then they kind of diverge from each other. And I've kind of gone ahead of myself. That was, what question was that?
That was B.
That's the next one. Sorry, I haven't created a table yet. I'm going to jump to question D here. So we have our point of intersection, okay? So the red line was representing the company where we paid $20 right off the bat, okay? And then $5 a day. Our black line represents where we pay $0 and then $40 a day. So you notice day 1 is $40, day 2, you can't really see, is $80, okay? Before 1 day passes, these lines already intersect each other. So on day 1, it's already cheaper to go with car rental company B, and because theirs is only going to cost $25, is it? Yep.
Yeah.
Where these guys are $40, and then it just gets steeper and steeper. The cost is even greater for company A. So it really makes sense to, assuming you're going to rent a car for more than 0 days, it really makes sense to use car company B. If you're not going to ever rent the car, then using this company is no good because you have to pay them $20 and then you never took the car out, right?
Yeah.
But assuming you are renting a car, company B is the better company. They want us to build a little table of values. What's great about this program is I can do that really quickly too. So here's a table of values, and here's another quick table of values. Okay. Now, in order for us to have built a table of values, we would have had to plug values in. Now, -2 and -1 aren't very important because we don't talk about negative days because the car company is not going to pay you money. Right? If you decide, oh, I'm not renting the car, so you owe me money, that doesn't actually happen in real life. We always start at 0. Mm-hmm. So 0, 0 would be our first point. 140 would be our second point, which is right here. 280, there's our third point. And I can even write in 3, and the program will zoom out just a bit here. The program will even put that value in for me. So here's 3 major points. And again, we start at 0. So if we rent the car for 0 days, costs us $20. A bit steep for that one company. Let's zoom in again. At 1 day, it's $25. At 2 days, it's $30. And at 3 days, it's $35. And in order to do that, all I did was plug in these values into the equation we created. Okay? So I know the order of questions here, they said state an equation. Oh, no, that was good. They gave us an equation, and then we would have built them, our table of values from there by plugging those values into the equation. Does that make sense how you build that table?
Yeah.
Okay with that? Okay. Point of intersection, we commented on it. That's where company A eventually surpasses company B as being the more expensive company, and it occurs before we even rent the car for a day. And how would you advise your friend as to which company to use? I would tell them, assuming you're going to rent a car, go with company B because it's going to be cheaper.
Yeah.
Right? In almost every case, unless for some weird reason you decide to drop $20 and walk out and never rent a car, which is a really odd thing to do. Okay, good.